which is properties of parallelograms. You have your guided notes. The first thing at the top is called, well, it's not a property, it's more of a definition. Do you see that written up at the top? And there's a line for it. If I were to ask you to define a parallelogram, now I'm going to flash back a little bit because the very first couple weeks of school we talked about the difference between properties of something and the definition of something, right? For example, this is a chair. Okay, it's easy to give me properties of a chair. What are some properties of a chair? You don't have to raise your hand.
Has a seat.
Has a seat. But wait, a stool can have a seat. Is a stool a chair?
Yeah.
It's a type of chair.
A Ferris wheel has a seat. Is a Ferris wheel a chair?
No.
So do you see how when you give me properties, does this have a seat? Yeah, it's a property of being a chair, right? Is having a seat the definition of being a chair? Not necessarily. So the definition is a lot harder to make up because it has to be bulletproof, right? You can't poke holes and break up the definition. It has to be good for any chair you're talking about. What's another property of this chair?
Has a cushion.
Has a cushion. This one does for sure. Does every chair have to have a cushion? No, so that wouldn't be a good definition, but it's a property for sure. This one has a back. It's another property. You see how it's more challenging to give a definition, right? So we're going to talk about what's the definition of a parallelogram. Anybody have an idea? Definition, not a property. Definition. Press.
It should be two sets of parallel sides.
Two sets of parallel sides. You agree? Disagree? Two sets of parallel sides. Nailed it. Well done. All right. So a quadrilateral, so it has to have four sides. And it has both pairs of opposite sides parallel. Both pairs, this is the definition. Both pairs of opposite sides are parallel. Good. So that is the definition of a parallelogram. So in your mind, categorize that. That is the definition. Quadrilateral, so four sides. Two pairs of opposite sides that are parallel. All right. Now let's get into some properties. Now, before you start writing these down, we're going to I think we're going to be able to find a shorter way to write this out. Okay. So with all of these theorems, you have a picture and then the theorem, right? We have the written out theorem. If a quadrilateral is a parallelogram, it has opposite sides that are congruent. I know, I'm getting to that in just a second. So this is a theorem, right? Do you see the picture? Can you picture what opposite sides being congruent look like? How does that differ from consecutive sides being congruent? Can you see that? That's a different shape. That's not what it's talking about. So here's what I'm getting at. On your paper, you don't have room for, or you don't have a space for the picture, but I would recommend probably on each line, we're going to draw just the picture right next to it. Now, what do you think is the easiest way to write this out as a property of a parallelogram? Do we really need to say if it's if the quadrilateral is a parallelogram? No, because what are we talking about? All four of these are talking about parallelograms, right? Okay, so give me the first property of a parallelogram. Its opposite sides are congruent. So if it were me, on line 1 for property, I would write opposite sides are congruent. And then draw this picture. The next one is opposite angles are congruent. Remember, opposite means across from, not consecutive, opposite. You are going to be responsible for knowing all four properties and the definition. Opposite sides are congruent, opposite angles are congruent. For the people who are still finishing writing, that's fine. Just if you're done, look up here real quick. I could prove this to you, right? It told us it's a parallelogram, correct? Aren't these sides parallel from what Preston told us? That's the definition. It's a parallelogram, has to have opposite sides parallel. Guess what? If you have two parallel lines and a transversal, consecutive angles are supplementary, right? See these parallel lines? Consecutive angles are supplementary. Consecutive angles are supplementary. See where I'm going with this? If S is supplementary to P and Q is supplementary to P, then Q and S must be, careful. If S is supplementary to P, give me an example of two angles that are supplementary. No, give me an example, like numbers. Give me two numbers that add up to equal 180. Let's not do that example. Let's make them different. 30 and 150. 150 and 30. Are you ready? Are these supplementary? Do you see how I showed you with parallel lines that consecutive angles are supplementary? You agree with that, right? Here's an example. What must angle Q be if these two are supplementary since there's consecutive interior? 150. Oh, look. If S is supplementary to P and Q is supplementary to P, then Q and S must be the same. Congruent supplements theorem. Remember that one? So what did we just prove? If these lines are parallel and these lines are parallel, opposite angles are congruent. You see it? We just proved it. Every case. Now, we gave an example to kind of make it come to life, but we could prove that for every single case. We just proved that opposite angles are congruent. So that was the second one. These ones, opposite sides are congruent. I think we learned that back in middle school, I believe. Next two, one I just proved to you. Consecutive angles, this is number 3. Consecutive angles are supplementary. Consecutive angles are supplementary. The book writes it this way for the picture. I'm going to give you an option on 2 ways to write this when you draw the picture. They write x, y, and then they make a little rule down here where x plus y adds up to equal 180. All right? There's another way to do it where you could say x, and then these angles are 180 minus x. Remember when we went to find a supplement of an angle, we did 180 minus the given angle. We found a supplement. If I say 30, what's its supplement? 150, right? 180 minus 30. So this is another way to write the same thing that's up there, if you don't want to have to write out this rule down here. And the last property of a parallelogram is that if you're told it's a parallelogram, the diagonals bisect each other. You have to write out, and I'm going to be very picky on this one. You have to write out diagonals bisect each other. You can't just write diagonals bisect, and I'll tell you why in a minute. You have to write out diagonals bisect each other. There's a chord there. All right. So the reason why we can't just write diagonals bisect and stop is because later on, we're not only going to learn properties of parallelograms, but rhombuses and squares and rectangles. And in other ones, other shapes, the diagonals are going to bisect angles. All right? So you can't just say diagonals bisect. Sometimes they bisect each other. Sometimes they bisect angles. It changes, so you have to be specific about which one you're talking about. So if we get in a good habit of writing that out for this one, then when we get into squares and rhombuses and so forth, we'll have a better idea of the other ones. Now, what does it mean to bisect each other? Well, diagonals are segments. When segments bisect segments, they create a pair of congruent segments, right? If I say this segment bisects this segment, I have one pair of congruent segments. If they bisect each other, this one cuts this one in half, boom, boom, and this one cuts this one in half, these are congruent. Make sense? Does that mean all four of these are congruent? No. Here's an example. This little guy just bisected this segment. This big segment just bisected this segment. That does not mean all four parts of segments are congruent, right? And there, if you kind of connect it, I just drew a parallelogram. See it? So if you draw two pairs of segments that bisect each other, you can draw a parallelogram out of it, all right? Because that's a property. It's a property of a parallelogram. All right, so we have our four properties. We already wrote down. Let's do an example of a proof, all right? So you're given it's a parallelogram. As soon as you're told it's a parallelogram, all four properties are fair game and the definition is fair game, okay? But this book, they like to mark things before they even talk about it. So we better write it down. We better write down first P, Q, R, S is A. And you're not going to want to write out the word parallelogram all the time. So we're going to use the symbol, which is completely fine. That is the symbol for a parallelogram. All right?
You have a different one.
Oh, is yours different?
Well, it's just a different,
It's the same.
like, it's just labeled.
Shoot.
I think it's like the same thing.
Let me change this one so it matches yours. All right, that way you guys don't have to. Everyone in the room has to change theirs. Thanks. All right, so you got A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D, A, D, B, C. Thank you. Now, some of you are still struggling with this when you're doing a proof, so I'm going to help you out again. Remember, just because something is marked in the picture or written in the given, It doesn't count unless it's in your statement column. Like there was an example before break where if I said AQ bisects PR and you wrote AQ bisects PR, it doesn't count as a tick mark until you've written out, oh, if this bisects this, then these two are congruent. You have to write it out. You can't just mark it in the picture. All right? So we have this as a parallelogram. As soon as you're told it's a parallelogram, all four properties are fair game, but you have to write them out. All right? Now, I would probably write out first. They marked it in the picture. We have to say it. AB parallel to CD and BC is parallel to DA. That's not given. That's not given. If it doesn't say it up in the given statement, you can't write given next to it. What is the reason I'm allowed to write that? That is the definition of a parallelogram. Preston, New Year's being good to you. Came back refreshed, ready to go. That's the definition of a parallelogram. Two pairs of opposite sides that are parallel. Not congruent, parallel. Parallel does not count as congruent, right? Same steepness doesn't mean that they're the same length necessarily. All right, now where are we going with this? We're trying to prove that AB is congruent to CD. How are we going to do that? Now, here's the tricky thing, okay? How many of you right now would say AB is congruent to CD, property of a parallelogram? I'd probably be tempted to write that, wouldn't you? AD congruent to BC, property of a parallelogram. Now, after today, that's going to be fair game, but we're proving that that is true. Like we're walking into class today and we're saying, okay, that's a property, it's a theorem, I should be able to prove that it's true. Are you with me? So I'm not going to write that today. I'm going to get there another way. All right? So here's my hint to you. We're going to prove that these two triangles are congruent first, and then show that those corresponding parts are congruent. How do we prove triangles are congruent? We have 5 ways. Go ahead and say them without, you don't have to raise your hand. SSS? ASA? Yes. SSS, SAS, ASA, AAS, and the weird one, HO. Good. So once we get to one of those, we'll be able to use CPCTC. All right. How do we get there? Yeah, there's a couple different ways to go right now. If you guys want to do the reflexive first, that's fine. BD congruent to DB. Reflexive property. We all agree these parallel symbols do not count as an S, right? They don't count. They're not congruent. They're parallel. They don't count yet. All right. What else? Anthony, you're jumping onto something. Alternate interior. Very good. Do you know which ones?
A, D, C.
ADC is this big angle.
Then it would be C, D, B.
CDB. I'll accept that. And
ABD.
good. ABD. If you wrote a different pair, that's fine. There's 2 sets of parallel lines here. There's multiple sets of alternate interior. If you didn't name the same ones he did, that's fine. Could you have done this one? Could you have done those pair? Yeah, that's fine. Just keep track of which ones you're doing. All right, angle. He said CBD. Nope, CDB. Sorry, CDB. Congruent to angle ABD. And those are alternate interior. Do we have SSS, SAS, ASA, AAS, or HL? Do we have one of those yet? No. So keep going. Now again, after today, could I say angle A is congruent to angle C because opposite angles are congruent? After today? Yes. But we can't use that right now because we're trying to prove the properties of the parallelogram, okay? So we have to stick with other stuff. So what else, Tally?
Could we do SAA by doing angles CBD and
CBD.
ADB, sorry.
ADB, these ones?
Yeah.
Yeah, and the reason for those?
Alternate interior
Good.
as well.
So if they're both alternate interior, I could put those on the same line. Because they have the same reason. And now we have, which one? Careful.
ASA.
ASA. Can you see it? Take a look if you can see ASA. If you can't, I will be happy. I have a couple little visual things we can do to make sure you see it. Triangle. ABD. Congruent to triangle. Let's see. CDB. ASA. Can everybody see ASA? You struggled with that before break. Do we see it again? Be honest with me. Who doesn't see it that it's ASA? All right, we have some people that are lying to us, but it's okay. All right. Are we there yet? Should we stop right now? Or is there a step 6? Step 6. AB. Congruent to CD. And AD. Congruent to BC by, what's that thing called again? CP. C. Corresponding parts of congruent triangles are congruent. And as you finish up writing, if you were to outline this triangle, remember ASA, it has 2 angles and a side. It's angle the side between the 2 angles. ASA, included side. 2 angles in the included side. Make sense? Awesome. Moving on. Applications of these properties. Here's some examples, and they should be on your guided notes. As you label these, you should kind of start to see like a puzzle, like it's telling you, hey, I'm labeling some diagonals. There's only one property that has to do with diagonals, right? Diagonals do what to each other? Bisect each other. But if it starts talking about angles, there's 2 properties about angles. One is that opposite angles are congruent. One is that consecutive angles are supplementary. So you kind of have to start to see what it's trying to tell you. So here we go. DE is 74. Should be labeling the picture. DG is 31. And FCD, here's what I like to do. If it's labeling a big angle, I highlight it with an arc mark, and then I put a little arrow, and I say 42 degrees. And now we're ready to start answering some questions. All right, here's CF. What's CF? 74 because opposite. Because opposite sides are congruent. All right, next one. EFC. EFC. C is this big angle right there. What do you think? Couldn't hear you over this phone vibrating.
Consecutive angles.
Thank you. Consecutive angles are supplementary. So with our calculators that are out,
38.
what's 180 minus 42? 138. Whose phone? If it's yours, you can go ahead and sign it. Is it someone's alarm? It's 9 o'clock. Yeah, you're like, I haven't seen 9 o'clock in 2 weeks. All right. WXYZ is a parallelogram. So this is very important. You can't start assuming these properties. I should have started with that. I read it, but we need to make sure we pay attention to that. We forgot to find DF. All right, Christian? DF. All right, what's DF? DF is not 31. It is 62 because it's the whole thing, right? And so you know G is the midpoint, right? G is the midpoint of both diagonals. And so if it asks you for the whole diagonal, you have to double it. Double that 31. Next one, you're also told this is a parallelogram. And so I see that 6a plus 10 is talking about a side and 8a minus 4 is talking about a side. And I know the property in a parallelogram talks about opposite sides being congruent. Congruent. Parallel wouldn't help us in this one, would it? Parallel wouldn't help us, but those being congruent would. What should we do with 6a plus 10 and 8a minus 4? Set them equal. 6a plus 10 equals 8a minus 4. Subtract 6a from both sides. Add 4. And a is 7. They didn't ask us for a. They asked us to find the measure of yz. So we're going to plug it in. 8 times 7 minus 4. What do you get? You guys agree 52? I agree. 52. What's WX? $52, right? Shouldn't even have to hesitate. 52. Opposite sides are congruent. 52. All right. Now to find angle Z. Well, angle Z, I have a couple options because in a parallelogram, it talks about, there's two properties talking about angles. One is opposite angles are congruent and consecutive angles are supplementary. Then you have to look at the picture and decide which one is it. Should I set two angles equal or should I add them up to equal 180? Add them up to equal 180. So this angle Z and this angle W, you want to, careful, add them up to equal 180. Add them up to equal 180. So we get 27b minus 9 equals 180. 27b equals 189. Divide by 27. What do you get? 7? $140, $49. Oh yeah. I was looking at 180. I'm like, no, 7 times 27 is 189. Yeah. 189. 7. But we want angle Z. Plug it in. 9 times 7 plus 2. What do you get? 65 degrees? 65 degrees. What if they asked for angle W? Okay.
Subtract 65 and 180.
Perfect. And what do you get? 115? I agree. You didn't ask us for that, but just to practice. I'm I'm sure it'll come up sometime. So we get 52 for YZ and 65 degrees for angle Z. All right, EFGH is a parallelogram. I want you guys to go ahead and solve this one on your own. You got all the tools you need. First thing you should ask yourself, yes? Sure. First thing you should ask yourself is, what property does this involve? What do you think? Yeah, diagonals bisect each other. Go ahead and solve it. All right, Josh, help me out. Let's do JG.
All right.
Now, to find JG, you had to solve for W first, right?
Yep.
So what'd you do?
You should put 3W equals W plus A.
Yep.
And then what I get? I got W equals 4. And then you just plug that into either one, and I got 12.
I got 12 also. Good job. Caden, help me out with FH.
I did 4z minus 9 equals 2z, and then subtract 2z from each side, and get 2z minus 9 equals 0 plus 9, and then divide by 2, and then equals 4.5, and I filled it in, and I got 18.
That's what I got. You guys agree? Just be careful. I think you would agree. You have to be careful. This one asked for the whole diagonal. This one asked for half of the diagonal. Just be careful when you plug it in that you're not just finding half of it all the time, right? All right, questions about those properties. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, and the diagonals bisect each other. 4 properties of a parallelogram, okay? Levi. Sure. All right. That is all for today. We're going to take it a little easy. All right. Second day on section 7.2 will be tomorrow. I'm kind of splitting up the homework. It's really only one homework assignment split up into 2 days. So today it's only 2 through 18 even on page 360. Even got 5 minutes to start it if you want.